grab a seat. We've got refreshments as well. We really appreciate folks being here this afternoon to learn a little bit about polysilicon. My name is Brooke Levy, and I'm the Vice President of External Affairs for Hemlock Semiconductor. We are one of 3 polysilicon producers in the United States. Polysilicon is something that you probably got this invitation is that, I've never heard of that, I don't exactly know what that is, but you are all using it, guaranteed. Raise your hand if you have a cell phone in your pocket. Yeah, so you have polysilicon in your pocket. Polysilicon is fundamental to electronics operating and also to the solar industry, and we're going to teach you about that today, share information about our industry and about the challenges that we face as an industry in the United States. We're really grateful to have this opportunity to address the Manufacturing Caucus and really appreciate the invitation to be here today. I want to start quickly by recognizing Congressman Newhouse from Washington, who is here with us today. He represents one of the companies that's up here, REC Silicon. Congressman, if you'd like to say a few words, we'd be happy to. Thank you.
Good afternoon, everybody. I'm delighted and just a little surprised that so many people want to learn about polysilicon. That's a great thing. It truly is an important component in so many things in our everyday lives. And it's also an important component of our economy. As you heard, there's a major manufacturer in my district, REC, in Moses Lake, Washington. That has been a huge part of the economy in Grant County, central Washington, and the solar panel industry. Unfortunately, one of their major customers is China. And I don't have to tell you some of the issues that we have in China right now, although our difficulty with China goes back even before some of the current issues that we're having. I shouldn't even use the word trade war, but I guess what else is a trade war is what we're seeing today. So it's tremendously important that we continue to keep polysilicon on the radar screen of our trade representatives. So anything you guys can do to help with that, increasing the awareness of the importance of this product throughout Washington, D.C. can do nothing but help. So thank you for your attention today, and we'll continue to work hard to make sure that this industry can be as strong as it can be. It's going to be one of those leading technologies as we go into the future. So thank you for having me for just a few minutes, and thank you for being here.
Thank you very much, Congressman. In addition, I'd like to introduce Kevin Jurens, who's here representing the co-chairs of the Manufacturing Caucus, Congressman Reed and Congressman Ryan, who unfortunately couldn't be here today, but we're really pleased to have Kevin here on their behalf to say a few opening words.
Thank you so much. And on behalf of the Manufacturing Caucus, let me welcome you. Unfortunately, Congressman Ryan is not able to make it, is who I work for, and Casey Morris works for Congressman Reed. Together we co-chair the caucus, so we're quite happy that you're here. Thank you to the panel for coming. Thank you to the Polysilicon Society for organizing them and hosting this event. So as the Manufacturing Caucus, we host various important events like this to inform Congress on important key issues that industry is facing. And so this is one of many events that we'll continue to host. And we're trying to understand key industry issues and identify ways how we can strengthen our economy through supporting our manufacturers. So we understand that polysilicon is a critical and strategic material for the U.S. We understand the importance of the polysilicon industry and products for materials for the products of our country. And so let me end there, but say thank you again and welcome to this panel session.
Thank you. You know, when we read a little bit about the Manufacturing Caucus, and really the mission of the caucus is engaging on policies where the U.S. can lead the world. And this is really a prime example of an industry where the U.S. has really led the world developing new technology, and unfortunately, now we're facing a situation where we don't have a level playing field with our foreign competitors. And that's really, again, one of the key issues that the Manufacturing Caucus looks to address. So we're really pleased, again, to be here and share this information with you. I will note as well that we'll be sharing information publicly through our own company, social media channels. We've shared some information as we came into the room. And if you're interested in helping us to amplify the message about polysilicon, please use our hashtag OpenPolyTrade and look at, please follow our company Twitter handles where you can get more information and help join the conversation and amplify that. With that, I'm going to have the members of our panel introduce themselves, and then Phil is going to lead us off.
Great, thanks, Brooke. I'm Phil Dombrowski. I'm the Chief Commercial Officer at Hemlock Semiconductor. We have a manufacturing facility in Hemlock, Michigan.
Mary Beth Hudson. I'm Vice President of Bauker's Polysilicon Division for the Americas region, and we have a manufacturing facility in Charleston, Tennessee.
I'm Francine Sullivan. I'm the Vice President of Business Development for REC Silicon. We have a manufacturing facility in Moses Lake, Washington, and Butte, Montana.
Great, thanks. I'll get us started. And again, I'd like to thank everybody for showing up today. It's really great you've come out to try to learn about polysilicon. I'd like to also thank the congressional representatives and staff that might watch this video in the future. We need your help, and that's why we're here. We're here to talk about some things that can be done to help our industry. You can see on the map that's up on the screen the polysilicon facilities. There are 3 in operation today in Tennessee, Michigan, and Montana. 2 polysilicon facilities have shut down, one in Texas and Hemlock's polysilicon facility in Tennessee. And REC had a plant, or still has a plant, in Moses Lake, Washington. It has been shuttered. It's not operating today, but they certainly would love to start that facility back up and hire people back. So if you see, the world has been through a couple of different ages, right? We've been through the industrial age, the atomic age, the space age. Today we're in the information age. And the information age depends on silicon. It is dependent. As Brooke said to start with, all of the electronic supply chain and the solar energy industry rely on polysilicon as its starting material. So what is polysilicon? Polysilicon is actually hyper-pure silicon metal. It is the basis of the electronics in the solar supply chain. And you can see the first picture there is actually what polysilicon looks like. It's little shiny rocks of pure silicon. The polysilicon we manufacture in the US is super pure. We measure impurities in parts per trillion. So a part per trillion, just to kind of give you a reference, if you stacked quarters from Earth to the moon, 1 part per trillion would be 1/4 in that stack. So we have to be very diligent in keeping our polysilicon super pure. It doesn't work. The solar cells and the electronics don't work unless the silicon is very pure. So you can see it's the basis of everything. The next step in the supply chain is ingot wafer. And that's where we run into a little bit of a problem, because the ingot wafer is where China kind of has the lock on the supply chain from the solar side. Here's some pictures of the plants. I mean, these are massive investments. These companies here have invested about $10 billion over the last 15 years in polysilicon production. A lot of that is idle now because of the trade issues with China. But you can see these plants, they are the refineries of the 21st century. We are refining silicon to build the economy for solar energy and for electronics. Here's a little bit of a view of what's happened in the polysilicon market. So polysilicon first was commercialized in the early 1960s, the dawn of the information age and the integrated circuit. It grew steadily as we all bought cell phones and TVs and DVD players, and it was great. At the start of the 21st century is really where solar started to take off. The blue bars on here are the semiconductor market. So how many really tons of polysilicon go into the semiconductor market? The green bars are what go into solar. And in 2008 was the first year where solar overtook the semiconductor market for polysilicon demand. And since then, today, 2019, solar is 15 times bigger than the electronics market. They're both still very important, But if you want to be successful in polysilicon, you have to be successful in the solar market. So that's what we're here to talk about. It's a big issue that we don't have access to that entire solar market. This should be a great story, right? That we ramped up all this demand over time, but what really happened was in 2012 is when our world changed, right? That's where we had the lock go on polysilicon being exported into China. So I'll let Mary Beth talk about what happened in 2012 that caused us to be shut out of that market.
Thank you, Bill. So you might think from that previous graph that the U.S. polysilicon manufacturers would benefit from this exponential growth. Unfortunately, that's not the case. And as Phil said, we effectively became locked out of the polysilicon supply to China. In 2012, the U.S. found that China was dumping solar cells and panels into the United States and imposed tariffs on these products. In 2014, China retaliated by imposing 57% tariffs on polysilicon from U.S. manufacturers going into China for the solar industry. This is significant because China accounts for over 90% of polysilicon consumed for the solar industry. So we effectively became blocked from the largest market globally. In 2015, China went on to announce their Made in China at 2025 initiative that specifically targets polysilicon for high-tech innovations. And then most recently, China imposed another 25% tariffs on top of the already 57% tariffs on polysilicon going into China for the solar market from the U.S. So the net effect has been, you can see on the graph at the right, the net effect has been that in 2011, the U.S. polysilicon manufacturers had over $1 billion of sales of polysilicon into China. Last year, it was about a tenth of that at just over $100 million of sales into China. The Made in China initiative is important to us because China is specifically targeting polysilicon for their advanced manufacturing. In the U.S. manufacturers have achieved the high purity polysilicon using high skilled labor at high wages, as a matter of fact, and then also utilizes advanced manufacturing techniques to produce this ultra high purity polysilicon that Phil was talking about. China would love to have access to this critical intellectual property and know-how. And already China has purchased one of the U.S. manufacturers of polysilicon specifically to gain that knowledge and intellectual property. We can't let this happen anymore. Not only are they targeting the polysilicon market from a technical standpoint for their advanced technical innovations, they're subsidizing investment in polysilicon manufacturing in China. If you look at the graphs in 2010, the U.S. actually had a bit higher capacity than China did in polysilicon manufacturing. Through Chinese subsidies of $1.6 billion direct, China has been able to invest in polysilicon manufacturing and now has a significant overcapacity. Not only has China directly provided subsidies, indirect subsidies of about tenfold of that $1.6 billion through financing and cheap energy has allowed Chinese manufacturers to have a significant advantage and continue to invest in the industry. So in summary, China's unfair trade practices have blocked U.S. polysilicon from the Chinese market. China's targeting polysilicon for technical dominance in the solar and semiconductor industries. They have actively been trying to acquire the critical IP to make the highest purity polysilicon that U.S. manufacturers can make. And they are providing incentives for Chinese companies to invest in additional manufacturing capacity. This chart shows the impact. So again, you can see the yellow line is the U.S. polysilicon manufacturers' market share in the 2012 timeframe. We had 24% of the China market in 2012 before the tariffs were imposed. Right now, we have about 2% of the market share. At that same time, the market has been growing dramatically, and Chinese manufacturers have grown with that market. If we had access to the Chinese market, we could immediately have $800 million of trade with China. So I'll turn it over to Francine to elaborate further on the impact to the U.S. manufacturers.
Thanks, Mary Beth. So I'm going to talk about some of the consequences of all this on both the solar supply chain and the US economy. The first thing I want to explain to you is that China's set out to monopolize the solar supply chain, and they've been very successful. This sets out the various steps in solar panel production. It starts with polysilicon, then it's solar ingots, then it's solar cells, and then it's solar panels. As you can see, those red parts of the pie of what China owns and controls. So they are monopolizing the solar supply chain right now. We sell, as polysilicon producers, we sell to solar ingot makers. And as you can see with that red pie, all that demand is concentrated in China. So they've been most successful in monopolizing solar ingot production right now, and they've locked us out of that market. So in terms of making solar ingots, the global market is China, and we are locked out of that market. And that's why we have such a huge problem right now. The end pie shows solar installation demand. So this is what you're all familiar with. This is people buying solar panels. This is solar farms in the US. The US has 12% of the global market. It's a very large market here in the US. And we have more than enough polysilicon to service domestic demand, but we cannot access domestic demand because we're blocked from that demand by China. So right now, most of the solar panels that are being installed in the US are made with Chinese polysilicon, which is an awful travesty really, given the very high-tech, state-of-the-art polysilicon capacity we have in this country. The other consequence to focus on, I think, is just the damage to the US industrial base by all of this. This all has serious consequences for the industrial base. If we lose these refineries of the 21st century, which Bill mentioned, we lose the ability to develop and maintain sustainable supply chains for solar, semiconductor, and lithium-ion batteries. Lithium-ion batteries is a developing source of demand for silicon. Silicon anodes are becoming very important for use in electric vehicles and lithium-ion batteries, and we will not be able to develop sustainable supply chains in these industries without polysilicon. As you know, if we lose manufacturing capability, we also lose R&D, and therefore we lock ourselves out of growth opportunities in these innovation industries. So it has a knock-on effect. All this has been concentrated in China, and of course gives China the upper hand to take advantage of developments in these important growth industries. And of course, the other consequence is that we're reliant on China for these important industries. We're reliant for energy generation equipment in solar. We will become reliant in semiconductor and batteries in due course if something's not done. The other big consequence to focus on, which gets very little attention, is that the concentration of polysilicon production in China has an environmental impact. As I said, we're installing solar panels in this country that contain Chinese polysilicon. And China is making its polysilicon using coal. All this new capacity that's being massively subsidised in China that Mary Beth mentioned is all being brought online using coal-fired capacity. Now this has a big impact on solar panels because polysilicon is the key determinant of the carbon footprint of a solar panel. That's where most of the carbon is used in the production of a solar panel in polysilicon production. In contrast, we have very energy efficient processes at REC Whopper and Hemlock, and we also use green forms of energy generation in our manufacturing. So, you know, the impact of this, I mean, I think it's important to understand that this actually does have a very real impact. For instance, if, you know, this is the equivalent, using Chinese polysilicon in solar panels rather than US-made polysilicon is the equivalent of adding millions of cars to US, internal combustion vehicles to US roads every year. If we're to meet SEIA's 2030 goals of having 20% solar generation or energy generation through solar by 2030, using solar panels containing Chinese polysilicon, that's the equivalent of adding an extra 125 million internal combustion vehicles to US roads. And the sad thing is we have, as I said earlier, we have more than enough polysilicon made in the US using the green process that we could be using instead. And I think the final consequence to focus on is the sort of granular economic impact. I guess we've had 2 plants shut down, as Phil mentioned. REC's Washington facility is shuttered. It's on the brink of a complete shutdown. You know, the cost of keeping this facility in shape so it could be restarted if we can access the global market again, which, as I said, is the China market. That's the market that we need access to because that's the global market, is around $20 million a year. So it's a very difficult, you know, these are very complex facilities, they're very expensive to maintain when they're shut down, to keep them in shape in order to be restarted. You know, from REC's perspective, to keep this plant, this capacity alive in the US, we need urgent access to the Chinese market. The other thing is, of course, we've laid off as an industry over 1,400 people over the last couple of years as a consequence of China blocking us from the global market. And these are high-paying jobs in rural communities with massive multiplying impacts. You know, this has devastated small towns. You know, in Moses Lake, we've seen a lot of, you know, companies, a lot of businesses, local businesses shut down as a result of this. And there will be more layoffs to come unless we can get access to the global market, which is China.
And these layoffs, they aren't in declining industries like coal.
Yeah.
These are growth industries that are growing exponentially, and we're losing U.S. manufacturing jobs.
So I'll turn it back over to Phil to talk about what we need.
So what can we do? Here's where we could definitely use your help. The most important thing that we need is access to the Chinese market. You saw that for solar, it's over 90% of the market for solar. And so we absolutely have to have access to China. We have to have our anti-dumping and countervailing duties removed, or some other way that we get access to China. If there's a phase 1 deal, we want polysilicon to be targeted. And we need it that simple. And so we have talked to USTR, and we are trying to engage the government to help us make sure that polysilicon is included in any settlement that's gone forward with China. The next thing the polysilicon suppliers are proposing is to expand the federal solar tax credit. This is the ITC. So today the ITC is given for any solar installations. What we're proposing is to essentially give an enhanced credit if panels are using U.S. polysilicon. So if a panel developer can demonstrate that they're using U.S. polysilicon, they would get an enhanced credit on top of the normal ITC. And then lastly, create investment incentives. You saw the 3 pies in the chart that Francine showed. We've essentially vacated the entire solar supply chain. We have polysilicon, that's the last piece left. We have lots of modules, but that entire supply chain, we have given it up. You know, we have given it to China, and we need to take some of it back. And so there's an opportunity, I think, to design some program and investment incentives to bring back some of the solar supply chain to the U.S. We'd like to have customers in the U.S. Right? None of us can supply to people in the U.S. because there's no customer. The customers are all somewhere else. So that's another area where we think there's an opportunity to help. Turn it back over to Brooke.
Thank you very much. Thank you guys so much. And I want to just take a minute. Congressman Gianforte has just joined us, and so we'd like to offer you a chance to come up and make some remarks as well. We've kind of just gone through the background, and we'll have a few moments to open it up for questions shortly, but please come up and make some remarks. Thank you so much for being here.
Sure, thank you. Well, I just want to say that this is an important issue for Montana. It's so important that we get manufacturing back on our shores. These tariffs have been a real issue, impacting businesses. I was in China myself this year in March. It was the first congressional delegation to China this year. We delivered a very clear message to the Chinese leadership in Beijing that we need to get a trade deal done. It was a bipartisan effort. We had the administration with us, and we need better deals, and we need them to respect intellectual property. We need enforcement mechanisms, and they said the right things, but the behavior hasn't always matched, and that's been the issue that we faced. So I understand the impact that these tariffs are having on businesses, and we'll continue to push to get free reciprocal agreements in place so that we can continue to expand U.S. manufacturing, which is so critical. So I just thank you for being here. And, our office is always open. Please feel free to reach out when we can help. So thanks.
Thank you very much.
Okay, so thank you guys so much for those remarks. And, I just want to reiterate again, as Phil said, really the most important piece for the polysilicon industry today is market access to China. And so we are really calling on our friends in the Congress and our friends in the administration, and so grateful to USTR for continuing to raise this issue throughout the negotiations, but they need to continue to hear from members of Congress that this is an important issue. We need to have polysilicon resolved in the Phase 1 trade deal, and that is our primary ask. We are also, as Phil said, working on these other things that are more maybe medium and long-term impacts for the industry, and that we'd like to discuss further with members' offices that also can drive further good impact for the polysilicon industry in the U.S. With that, I think we'd like to open this up to questions so that if folks want to have some clarification around things that they've heard today, understand a little bit more about the industry, the impacts of the industry, and the challenges that we're facing, and the solutions that we're seeking, that we can clarify those for you while you're here. So please.
So if the markets are open, I'm trying to understand what this looks like. I assume that means the 57% tariff would go away, but can you even compete then when China is still, in their market structure is so different, so they're still subsidizing that industry, so they're still producing, and they have control of that supply chain. So what does that look like to really have an open market?
Thanks for the question, Maddie. We definitely can compete. The polysilicon made in the United States is of the highest quality. There are customers in China that are begging to get our polysilicon. They would love to have it. We just don't have market access. And we can compete on cost too. A lot of times people say, oh, you can't do it as cheaply. We can compete on cost head to head with China, right? So I think if we have market access, that's why we showed that number of 800 million. We've given that number to USTR too and said, look, if one of the goals of China is reducing the trade deficit, here's 800 million. Yeah, it's not 30 billion, but it's a start, right? And so we think we can get that quickly.
We have a preferred product and we have better technology. That's why we can be lower cost.
And we have state-of-the-art processes that are much more efficient than the Chinese manufacturing processes. Our biggest issue with competitiveness is plant loading. So if we are able to access the market, then we can load our plants immediately and be competitive.
Other questions? Yes, please.
What do you think of offering a trade deal that will make the Chinese open up their markets to your policy?
So the question was, what do we think could be offered in the trade deal to open up, that would convince the Chinese to open up the markets? Is that the question?
Well, I guess I'll start. I mean, I think USTR's position is, why should we have to offer something? These were basically retaliatory tariffs, and they shouldn't have been put there in the first place. And so I think USTR's position is, we're not really willing to offer anything in this particular case. Certainly, it's a broad trade deal, so there's lots of back and forth, whether it's ag products or other things. So we're not privy to the detailed negotiations at USTR, but I think there are opportunities. I think for us, though, China recognizes these are retaliatory, and they should probably be gone or never even put in place.
Didn't they start with us putting a tariff on their product?
So the day, it was on their finished product,
Oh, okay.
the solar cells and panels, so it was downstream, far removed from the polysilicon itself. There was no legitimate market basis for tariffs on polysilicon.
This was a strategic move, right? This was classic 301 behaviour, you know, blocking us from the market and massively subsidising American players, then buying US technology really cheap, you know, from a company that they helped send back from. You know, this falls into, you know, exactly what the 301 is designed to address. So that's why we're hopeful we should be, and we believe we should be part of this trade deal.
I was wondering if there was any options or even possibilities for different markets, new markets outside of China. Could we grow new markets for polysilicon? Is that even an option?
New markets for polysilicon?
Oh, yeah, I mean, you know, we're seeing an opportunity in the electric vehicle space in terms of supplying silicon to silicon anodes. That's the next catalyst for reducing the price and size of batteries and getting better performance. But that demand's a couple of years away. You know, the electric vehicle market and the lithium-ion battery market will be a very exciting market. But the demand, you know, is not going to really manifest to allow us to load our plants, as Marika has said, in a way, you know, where we can just supply that market for, you know, maybe 8 or 10 years. But that, you know, that market's certainly there, and that's one of the reasons, as I pointed out, it's really important to keep this industry around.
For existing markets, are there other countries that can contribute in, say, solar or?
So again, the majority of polysilicon, over 90% of polysilicon for the solar market is in China.
Currently.
And that's, there are barriers for entry. It's not a fast investment to be able to produce the units and wafers somewhere else. There is a basis for semiconductor supply, but you've seen on the graph, one of the first graphs that Phil showed, that market is pretty steady, mainly because even though our demand for electronics is increasing, we're also demanding that those electronics be smaller. So think of the size of the chip that's in your cell phone versus the size of a solar panel and the number of solar panels that you would need to generate energy, say, on your house. Just by the nature, you're going to consume a lot more polysilicon in the solar industry.
And make no mistake, the Chinese have the semiconductor industry in their crosshairs. It's next. Right? I mean, they've publicly stated it. They're investing. They're subsidizing that industry probably 10 times in the solar industry. $50, $100 billion. So they are targeting that one next.
So,
Oh, excuse me, just 1 second. We just had Congressman Molinar join us, and so Congressman Molinar represents the Hemlock facility and has been a real champion for the polysilicon industry, really from his time in the state legislature to now in Congress, and so I want to welcome you and ask you to come make some remarks
thank you.
as well. Thanks.
Well, thanks. Nice to see everybody. Thanks for getting together, and I appreciate the chance to be with you. And as Brooke said, you know, Hemlock Semiconductor employs over 1,000 people in my district. It's a great opportunity for people in rural Michigan to have jobs. It's a very important contributor to our economy in Michigan in general. You know, you think about Silicon Valley, and you know, I know you've already had a panel discussion, so I don't want to repeat things, but you think about the ways our lives have improved because of the work that's been done. And polysilicon manufacturing has been a big part. And when I think of whether it's solar panels, I know you were talking about earlier, when you think about the computer chips that are used in our everyday lives, polysilicon manufacturing is such a vital part of that. And when I consider what China's strategy has been really since 2013, has been really to target our polysilicon industry. And whether it's through their China, Made in China 2025 strategy, whether it's acquiring our technology, whether it's subsidizing their industry or putting protective barriers in place through tariffs, it's really done a lot of harm to our polysilicon industry. And as a result, it's affected jobs. I know in Tennessee, there was a $2 billion plant that was moving forward, and because of this unfair competition, it really caused that to be shuttered. So I'm very concerned about this. You know, when I think of the negotiations with China right now, I think it's important that we don't have a foreign industrial policy determining what we make in this country. And we have been leaders in this area, and so I hope that the U.S. Trade Representative will really advocate for this area in U.S. polysilicon manufacturing and as part of those negotiations and be successful, because jobs depend on that now as well as in the future, because I think, you know, solar power is perhaps the fastest growing source of energy. When you think of our technology that we use computer chips for, it's incredible, and we should really be building that here. And so that's why I wanted to come and speak to you today, and I'm just grateful for the opportunity. And I know they're going to call folks in a few minutes, so I apologize for coming and going. But yeah, honored to be here. And I know you've got a distinguished panel here, so they'll probably be able to go into a lot more detail. But thank you very much.
Thank you.
I also just want to offer an opportunity. Representative Desjardins had planned to be here today, and his representative Cody Rhodes is here and would like to say a few words on behalf of Caucus Desjardins as well. Thanks.
Well, thank you everyone for being here. I work for Congressman Desjardins. He's the Tennessee 4th Congressional District, and Walker is in our district, and we're very supportive of them. Walker is a very good employer in our district, over 700 high-paying jobs and very high technical jobs. So, you know, obviously this trade war, it's been difficult for them and the polysilicon industry, and we just want to make sure that Congressman Desjardins knows what you are going through and that we're very supportive of you all in the manufacturing caucus and the polysilicon industry. And hopefully, you know, something is reached here soon with the trade negotiations. Appreciate being here, and Congressman, sorry he's not able to be here, but he got tied up in a meeting, so, you know, I'm here today, so thank you.
Thank you.
I think we have time to take some more questions. I know there were other hands raised in the audience, so.
Yeah. I was
yes.
going to ask why you're willing to cede the solar cell market to China to save yourself. You know, I mean, you have, you know, you did mention the third leg, but you know, you keep mentioning 90% is there, and therefore we must. When another solution, of course, is not to cede, and they own that market for the very same reason they're owning yours, right? And so, don't you think a more holistic solution is appropriate, rather than a focused one that cedes that market to them so you may survive?
We don't want to cede that market to them.
Well, it sounded like, oh, you know, China has 90%, therefore we must sell to them.
Well, we've got to be realistic though. I think, you know, longer term, we want to develop a whole value chain here to service the US should be self-sufficient. This is becoming a mainstream energy source.
Yes.
The US should be self-sufficient in solar component manufacturing. Right now, you have adequate, competitive polysilicon capacity to serve downstream demand, but we can't get access to downstream demand. So we've got to be realistic. We've got to get back into the global market so we can get back into full production, and then we've got to build the rest of the value chain. And I think Phil pointed that out, you know, in sort of what we need. We need some help to build the rest of the value chain.
So So you're not for pulling the tariffs on the solar cells that are being done, right? You're not for that?
No, that's not what we're
Okay.
saying at
All
all.
right.
If you look across the value chain, it goes from polysilicon, that is the highest technology, the highest investment cost, in the most technical of the value chain, to the least technical for the panels, the modules. And so the investment in the lower end of the value chain is pretty quick, pretty easy. And we have seen a lot of investment in the U.S. just in the last year or two.
What increase has there been?
I cannot tell you off the top of my head.
Most of it has been in panels. So the panels are not a high capital investment. So actually after the 201 tariffs, there were some panel manufacturers that located production capacity here. Elgin Chemical, Jinko Solar, Hanwha, SunPower purchased a facility that used to be run by Solar World. So there was some U.S. manufacturing. It wasn't enough, nearly enough, to supply the U.S. market. Unfortunately, none of the cell manufacturing came back. There's really only one cell manufacturer in the U.S. right now. That's Panasonic Tesla. They're barely running. And there's no ingot wafer. So we would love to see customers. I mentioned that. I'd love to have ingot wafer customers here in the United States. But today we don't. And that takes time. So that was the third part of our, hey, let's put some strategy around bringing U.S. investment back. So we have ingot wafer. Because we think even ingot wafer could be competitive here in the U.S. You know, the reason it's more competitive in China is, you know, they don't follow all of the same environmental standards we do. Ingot wafering uses a lot of water. It can be environmentally unfriendly. And so we just, you know, and then China has dominated this. But in the U.S., we think we could do it here also. You know, maybe not quite as cost effective, but certainly close to cost effective, and probably much better from an environmental standpoint.
And again, it's the essence of time. We could immediately, tomorrow, start supplying the Chinese market with polysilicon. It would take years to invest, for someone to invest in significant capital to invest in cell manufacturing here. We don't have the luxury at our time.
It's a great question, though.
Yes, I have a question. You kept mentioning the high-paying jobs, and there are lots of them. Do you have any figures around that? How many jobs are there in the industry? You mentioned that 1,400 have been lost, but what's the total size, and what is the annual wage across the industry?
Well, I can tell you at Hemlock, I don't have the statistics on wage. Hemlock today employs, you know, with our contract workforce, we have somewhere around 1,500 employees at the Hemlock facility. A lot of those are professional engineering roles, management, finance, accountants, you know, a lot of those kinds of things. And then skilled trades, right? We use a lot of millwrights and pipe fitters. So those are the kind of jobs we're talking about, including the operations people who run the plants. So again, those wages are high, even if they're on the hourly side. I don't know the numbers, but way, way above kind of U.S. averages. So I mean, that's the Hemlock position.
And likewise, we have roughly 700 direct employees at our facility in Tennessee. And the National Association of Manufacturers will tell you that there are 4 to 7 jobs in the community for every one manufacturing job. And again, these are high-skilled jobs that require advanced technical training. So they would be on par with the national averages for someone with anywhere from an associate's degree in a technical field for the technicians, the operators, all the way to the engineering. And just to give you an example, entry-level engineers with a bachelor's degree are getting around $70,000 a year right out of school.
REC, we have around 280 people left. We've laid off over 200 people because of China's actions to try and monopolize this industry. We're a public company, and I believe we've disclosed that, you know, the recent layoffs, I think the average salary of the person laid off was over $100,000 a year. These are very sophisticated jobs.
Those are manufacturing workers or
Yes.
across the board?
That was the average wage of the people laid off, and they were mainly operators. These are very sophisticated, very high-tech jobs with a massive multiplier impact in the community.
And just a real quick follow-up, how automated are those production facilities. You showed us the big plants. I was just curious as to the level of automation in those plants. Is it labor intensive when it comes to the production, or is it highly automated?
We have over 10,000 points that we monitor and bring into our process control computer systems that operate the plant. So that should give you an idea of the level of automation.
Yeah, it's a giant chemical process. So chemical processes aren't real labor intensive. You have people monitoring processes, starting some things, stopping some others. Where it gets more labor intensive is when you harvest the polysilicon and when you package and break the polysilicon. And then of course all the labor that goes into the hands-on maintenance. Again, $10 billion of investment. If you look at, plants have to be maintained. That's tens of millions of dollars every year in new capital we have to put in to maintain the plant, make sure we're doing all of our preventive maintenance. It's a lot of extra work just to go through and do that.
In late 2017, the Trump administration issued an executive order on critical minerals. And then earlier this year, the Department of Commerce and Interior co-published a report, a call to action. Is there any kind of leveraging or synergy between what you're pushing today and what was found in the report and what you're trying to do?
The question was around critical minerals, and if there's a synergy or leverage.
Yeah, I think the experience of this industry is very, very similar to the experience of that industry. China went after that industry as well, right, for very strategic reasons, in order to control their supply chains and exercise monopoly power. And that's what they're doing here. They know how critical this strategic raw material is to these important industries like semiconductor, solar, and in the future, lithium-ion batteries. Yes, so maybe there's something we can do similar to what they do. It's a very similar issue.
Does polysilicon constitute or qualify as a critical minerals?
I'm not sure I know what the definition is, but one of the things is it's not like rare earth metals. It's a similar kind of thing, but silicon is the second most abundant element on the face of the earth. Right? Sand is SiO2. So there's a lot of silicon. Now, refined silicon, polysilicon, is a lot rarer and a lot harder to get to. So you can't qualify silicon metal as rare, but certainly polysilicon in the form we make it, in the purity we make it, is very difficult. And it is a national treasure. We need to have it to be successful.
Can you guys speak a little bit more about where you fit in the supply chain, kind of what comes into your factories, what comes out, and where are the customers, who are you selling to, kind of more detail?
Yeah. So we're buying metallurgical grade silicon metal. It's roughly 98% purity. And we are basically just purifying that to measure the impurity levels in the part per trillion range. And just like Phil had described, it's ultra pure polysilicon. So the process is we get those silicon atoms in a form where we can remove the impurities via distillation, very similar to the process to make whiskey. And then we redeposit those silicon atoms into a solid form, and we crush it into various sizes so that our customers can take those basically silicon, hyperpure silicon rocks, and put them in crucibles and melt them to form the ingots. And then those get sliced into wafers and then ultimately processed into the cells, the modules, and the end product solar panels.
If you're interested afterwards, I have a piece of polysilicon in my computer. I can let you touch it and see what it is. It's not very pure anymore because a lot of people touch it.
Is the purity that allows that high efficiency for the end systems that are installed.
Yeah, what are the national security implications if we don't have a polysilicon industry in the United States?
We're relying on China for these strategic raw materials in a similar, vulnerability situations in relation to the rare materials.
Yeah, I mean, it's certainly important in the solar space. In semiconductor, it's really critical, right? I mean, there just aren't that many companies that can make semiconductor-grade polysilicon. and China is targeting that next. And if we're gonna rely on China for polysilicon, then you're relying on them for semiconductor wafers, and then you end up relying on them for the semiconductor supply chain. And that's a scary thought, right? And you know, that has defense implications. It has other kinds of implications, right? Which is why the US government has been so concerned about Huawei and others about, well, do we really want Chinese companies creating the backbone of our infrastructure? We probably don't. We probably want to have our own supply chains for those things.
This is just a clarifying question. I think what you said is that China has managed to bottleneck the entire supply chain through its own industries, so that despite us having great polysilicon production facilities, we basically have to send it all to China before we make the finished product. Could you speak to the change in the fraction of U.S. exports to China between 2012 and now? Like what percentage of U.S. polysilicon was going to the Chinese facilities?
It was at the end, is the less than 2%
This chart.
is going into China right now for the solar applications. It was 24% prior to the tariffs being in place. So it's been a-
So I must have misinterpreted. I saw this as the market share. I'm sorry.
Yeah, the yellow line here is, and it's red on the right, on the right axis. It starts at about 24% market share. That's what the U.S. used to have. That was our market share in China, and as soon as they put it.
So I'm asking a slightly different question, I guess. I'm asking what fraction of the polysilicon produced in the U.S. goes to China.
Essentially zero. I mean,
Yeah,
it's 2% today, so it's a very, very small amount.
And was it a large?
yeah,
fraction
if
in
you
2012?
look at the capacities in 2011, I think in Phil's chart at the beginning, we actually had a higher capacity of polysilicon in the U.S. than China. So we were a major supplier to China. Actually, Wacker built our plant knowing that the market was in China, but we didn't want to lose our intellectual property. So we chose to invest in the U.S. with the expectation of shipping our finished product to China. Unfortunately, that hasn't materialized.
Yeah, Hemlock did the same. We put a, close to $2 billion plant in Tennessee, and we built that, and we're preparing to start it up when China closed the door to U.S. polysilicon, and we were never able to start that plant because we had no market for that output.
What's happening is, as China continues to invest, they push other consumers of polysilicon outside of China. They push them out of business. So the market outside of China is actually diminishing at the expense of China investing.
That pie that I talked about, that our off-takers, that used to be less red. That's got gradually more and more red, kind of as every month goes by. Actually, right now, I think their plan is to try and make that whole thing red, if they have their way.
I think we have one more question, and then
Has the U.S. pursued WTO arbitration at all? And if so, is anything come of that?
We haven't pursued WTO arbitration. It's come up in the past. The issue is it's a political issue with China, and the way that it likely gets settled is politically. I mean, we thought about taking WTO challenges, but in the end, I think what's going to be most successful is China, the U.S. and China find a way to settle this. I mean, China won't say they were retaliatory duties, but they know that they were. And so that's really the injustice here, is that the retaliatory duties were put in place. We talked about why did they go all the way back to polysilicon? Because that's the only thing they import. They didn't import cells or modules from the U.S. The only thing they could go back to was polysilicon. So it's unfortunate. We were kind of the collateral damage in the solar trade war, and it's unfortunate because we were the leaders in the industry, and we still are the technology leaders. We just don't have access to the market.
well, Well, I just want to say thank you. This has been really great. The level of engagement and questions has been phenomenal. We've been happy to share this information and this story with you. I go back to what I started with. If you learned something interesting here today, please share information. We need to raise the profile of this issue. Our ask of Congress is to help weigh in with the U.S. Trade Representative's office and the administration on this current trade deal to get market access now to China. So we ask you to take that message back and help us to amplify what you've learned here today. All of us will be available to answer questions afterwards as well. And yes, Casey, please do accept. Yeah.
For the House Manufacturing Caucus, just so you're all aware, this is being videotaped and it'll be on the website. So if you want to share it with other people in your office or people you know, please do. And also, we will be having another event next week on rapid process intensification with the Manufacturing USA Institutes, which you are all welcome to. If you're not already on the caucus list, please have your offices join, or if you happen to be from the Senate, you can talk to me, give me your business card, and we can make sure you